Hello, welcome back to our channel. Today we are going to discuss about electric potential and capacitance. In complete part 1 we are going to discuss about electric potential. So what is the electric potential? Suppose one object is there. You want to bring from one place to the another place. What you are saying, work is done on the body. Like that, in the electric potential, the amount of work is required to bring the unit positive test charge from infinite distance, that is called the work done. Simply we can show that. Look here, this is the one charge. It is producing the intensity of electric field like this. Now you want to bring one positive charge from infinity to a point A, that is represented by X from here. So amount of energy is required to bring the unit positive charge is called the electric potential. So electric potential formula is, observe clearly here, V equals to W by Q naught. Simply what do you say? This is the work per unit positive charge. Force per unit positive charge is the intensity of electric field. Like that, work per unit charge is called the electric potential. Suppose work equals to 100 dynes and Q naught equals to 20 microcoulombs. Then how to find out the potential here? V equals to 100 dynes, we must convert into newtons, 10 to the power of minus 5 newtons, by 20 microcoulombs means we can take it 10 power minus 6. After simplification, this is 12 pi, and here when one decimal is going up, you are getting 50 volts. Like that, when you know the work and charge, we can able to find out the electric potential. You remember that it is a scalar quantity. It is a scalar quantity. Then unit is the volts or joules per coulomb also you can take it. Then one more formula is there. This is in terms of work and charge. Here potential due to point charge. Potential due to point charge. What we are taking here in this case, you remember that V equals to 1 by 4 pi epsilon naught Q by R. You know that Coulomb's force is 1 by 4 pi epsilon naught Q1 Q2 by R square. Intensity is 1 by 4 pi epsilon naught Q by R square. But potential, you see, V equals to 1 by 4 pi epsilon naught Q by R. So this is the electric potential. Here also we do one problem. If Q equals to 5 microcoulombs and R equals to 1 centimeter. Find the electric potential means, instead of this 9 into 10 power 9, instead of Q 5 into 10 power minus 6 centimeters, we are converting into meters, minus 4. After simplification, 45 into 10 to the power of 5 volts. This is the potential due to point charge. This is in terms of work done, how to find out the potential. And here one more formula you can say, work done, you can write it V into Q naught also. This is the work done formula. Then potential difference. What is the potential difference? The potential difference between 2 points. Suppose you should consider this is the A and this is the B. So VAB means it is moving from A to B, but which is more potential, VB minus VA, you can take it. The difference of potential between 2 points is called the potential difference. It is represented by VAB equals to VB minus VA. Suppose VB is the 100 volts and VA is the 50 volts. Then what is the difference between them? 100 minus 50. We can able to find out the 50 volts. Now we can go through the potential due to number of charges. See, this is the Q1, this is the Q2, this is the Qn. Here the distances are how much? R1, R2, R3, like that. So how to find out the potential here? Algebraic sum of the individual potentials. V1 plus V2 plus V3, like that we can find out the individual potentials. Now electric potential due to an electric dipole. an electric dipole. See, here we are taking an electric dipole. This is the positive and this is the negative. Here the distance is A. Here we want to find out. Here the consider R. After it will make an angle theta. After simplification, just you remember that electric dipole is V equals to 1 by 4 pi epsilon naught P cos theta by 2P cos theta by R square. This is the formula for electric potential due to an electric dipole. Based on the theta, we can change this value. Now, we can go through the, for axial line, theta equals to 0, we are getting 1 by 4 pi epsilon naught 2P by R square. For equatorial line, theta equals to 90 degrees means there is no electric potential for that. So, this is about the electric potential, potential difference, electric potential due to an electric dipole. Now, we are going to discuss about relation between E and V. Means V is the function of the distance. Relation between E and V, look here. Generally we can take it E equals to minus dV by dr. Means rate of change of potential with respect to distance is giving the intensity. It should be right dV equals to minus EdR. Then dV equals to, we can write it minus E bar dot dr bar also we are writing. We do one problem also, look here. If E bar equals to 2I cap minus J cap minus 5K cap, then R1 is the I cap minus 2J cap plus 5K cap. Then R2 is 2I cap minus J cap plus 2K cap. So how to do this one? Difference of these two. You have started at R1 and you reach to the R2. How much displacement? R2 minus R1. Here how to find out the potential here? V equals to E bar dot D bar. Small part means we have taken dV here. See, E bar is this one. First of all, R2 minus R1 we are taking. This is I cap. This is plus J cap. 2K minus 5K cap is the cap. Then V equals to E bar dot dr bar or delta R bar. See, dot product means this is how much? First one is the 2 minus 1 plus 15. After simplification, 16 volts. Like that. If they are giving minus means this is scalar. We are getting 16 only. If minus means you can express that also minus 16 like that. So with the help of the dot product also we can able to find out the electric potential. Then few more formulas. This concept we are using in semiconductors also. So don't forget the relation between intensity and potential. Look here. We are taking both the sides integrations. Minus E bar dot D bar. So if E bar E equals to 2R square 3R square plus 4R cube plus 6R plus 2. Find V at R equals to 0 to R equals to 1 meter. So what we have to do? Just we have to do the integration. Here differentiation integration cancel. V equals to minus integration of 3R square into dr. I am splitting this one. 4 into R cube into dr plus 6 into R into dr plus 2 into integration of r. But clearly they have mentioned in the limitations. It is 0 to 1, 0 to 1, 0 to 1, 0 to 1 like that you can take it. So V equals to how much it is? 3R cube. This is 3 into R cube by 3 plus 4 into R to the power of 4 by 4 because integration of R cube n plus 1 by n plus 1 we are using. 6 into R square by 2 because power 1 is there. Here differentiation integration cancel 2 into R. But for everything 0, 1, 0, 1, 0, 1, 0, 1 limitations. This one cancel, this one cancel, 2, 3 jump. Then you should apply the limitations here. What you are getting? See, V equals to, minus is the common for R. R cube, instead of R we are writing 1 minus 0 cube, 1 only we are getting. Then plus R to the power of 4 means 1 only. Plus R square also 1 only. Plus here 2 into 1 2, because 0 no need of applying here. So this is the electric potential we are getting, minus, this is 3 plus 2 5 volts. Like that, with the help of the dot product also we can find out the electric potential, and with the help of the integration also we can find out the electric potential. Like that, we do one more problem here. With the help of differentiation also we can able to find out. Here I have written formulas one by one. Look here. Then in semiconductor, simply you should write it E equals to V by D also. V belongs to, otherwise V by R. V belongs to potential. R is the distance, thickness, anything you can take it. This is the relation between this one. So these applications we can apply for conducting sphere, conducting sheet, and one more is the conducting long straight rod, like that, anything infinite long conducting sheet. So we should apply that. When you know the intensity, you can able to find out the potential. Look here. For long straight conductor, I have given third part from the electric charges and fields. Their intensity, what is the formula? Lambda by 2 pi epsilon naught into R. When you know this, how to find out the potential? V equals to integration of EdR. So here lambda is constant, minus lambda by 2 pi epsilon naught integration of 1 by R into dr. What is the formula for this? Lambda by 2 pi epsilon naught 1 by R is the log E R plus constant. So when you know the intensity of this one, we can able to find out the electric potential also. Like that, for plane sheet, like this we have taken. Here, what is the intensity of electric field? E equals to sigma by 2 epsilon naught. When you know the intensity, how to find out the potential? Minus sigma by 2 epsilon naught into dr. Like that you should take it. But here minus sigma by 2 epsilon naught is the constant. Integration, differentiation cancel, plus constant you are getting. So just we have to do the integration of intensity, we will get the potential. Like that we can take it. One sphere, conducting sphere means entire charge is distributing on the surface. Outside, inside, this radius is how much? R. We should consider a small r at point P. This is the distance. First case, intensity, what is the formula? 1 by 4 pi epsilon naught Q by R square. So here, how to find out the potential? V equals to minus 1 by 4 pi epsilon naught Q is the constant, integration of R square into dr. So 1 by R square into dr. Then V equals to minus 1 by 4 pi epsilon naught Q, integration of 1 by R square is the minus 1 by R plus constant. Look here, minus minus plus, finally you are getting V equals to 1 by 4 pi epsilon naught Q by R plus constant. Like that, on the, suppose the distance is only here, R equals to R. So second case, on this sphere, what is electric potential? Instead of small r, we are taking capital R, 1 by 4 pi epsilon naught Q by R. But this is very important, last one. Concept questions also they are asking. Where the intensity is 0 but potential is not 0 means in the case of conducting sphere, inside the charge is 0. Here entire charge is distributing on the surface. So inside, what is the charge? Inside the charge equals to 0. So here intensity is 0, but we know that what is the relation? E is 0 means dV by dr equals to 0. So V equals to constant. Like that we can able to find out the electric potential in the case of conducting sphere, in the case of plane sheet, and in the case of linear conductor, and this is the relation between intensity and potential. Now we are going to discuss about potential energy on the electric dipole placed in uniform electric field. Actually, it is the continuation of the torque acting on the electric dipole. Same here we are taking, see, potential energy on electric dipole placed in uniform electric field. Here, this is the intensity of electric field. Here we are placing inside that one electric dipole positive charge, and this is the negative charge. One force is this, one force is this. Tau equals to how much? P is sin theta. When you know the torque is nothing but turning effect of the force. Then how to find out the work done here? Look, work done equals to integration of turning effect of force into angular displacement. So when you are placing instead of tau, P is sin theta into d theta. Here P is the 2A into Q, dipole moment. E is the intensity of electric field. Then work done equals to, see here minus is there. Then P equals to, sorry, this one only, no minus, P equals to integration of sin theta into d theta. But integration of sin theta, what is the formula? Minus cos theta. So minus P cos theta. It is stored as a potential, means U equals to minus P cos theta we are taking. Then look here, U minimum equals to minus P when theta equals to 180 degrees. Like that, U minimum equals to, we are getting at 0 degrees, cos 0 equals to 1 minus PE. Like that, U maximum equals to PE only when theta equals to 180 degrees. Suppose it is 90 degrees, what we are getting? Cos 90 equals to 0, U equals to 0. Generally, we can say that maximum and minimum for 0 and 90 degrees, but here you should observe that maximum is for 180 degrees and minimum is for 0 degrees. This is about the potential energy. Then suppose if P equals to, and one more concept, it is rotated from theta 1 to theta 2. Then how to write this expression? U equals to minus P. First you can take the upper limit, cos theta 2 minus cos theta. Here minus is there, don't forget. So it should be right, cos theta 1 minus cos theta 2 also we can write it. We do one problem here. If P equals to 4 and E equals to 10 Newton per Coulomb and Coulomb meter. Theta 1 is the 60 degrees and theta 2 is the 30 degrees. How to find out the potential energy? Substitute all values. Here P equals to 4. P into E, how much? 40. Coulomb meter, not centimeter it is. Cos theta 1. Theta 1 is how much? 61 by 2. This is the root 3 by 2. After simplification, 40 by 2 into 1 minus 2 joules. Like that we can find out the how much potential energy is acting on the electric dipole. So this is about the electric potential. I have revised 90% formulas. So better you should follow this. And already in that previous MSET question paper, I have discussed electric potential and capacitance problems also. Better you follow that one also. It is very useful for you. And one more concept here we can take it, electric potential. Look. Suppose one big drop is there. One big drop is there. This radius is R. It is split into n number of drops. Each drop radius is n. Here which is constant, volume is constant. 4/3 pi r cube equals to 4/3 n into pi r cube. These two are constant. R equals to n to the power of 1 by 3 into R. This is the relation. Here why I am giving, suppose this is the small drop, 1 by 4 pi epsilon naught q by radius is we are taking R cube. Suppose this small drop, n number of drops are combine and it will give the big drop. Then what about the potential Vs dash equals to 1 by 4 pi epsilon naught. Q becomes to n times of the charge, but here instead of small r, what we are writing, r into n to the power of 1 by 3. Then it should be right 1 by 4 pi epsilon naught Q by r is the potential. So n by n power 1 by 3 is the n by 1 minus 1 by 3 is how much? This is the 2 by 3. One problem also we are doing, if n equals to 64, then V equals to 2 volts. Then big drop potential is how much? Vs2 into n value how much? 64. We are writing 4 4 16 4 like 64 4 cube. This is the 2 by 3. 3 3 cancel. V dash equals to 2 into 4 square is how much? 16. V dash equals to 32 volts. Like that we can solve this type of problems. So thank you everyone. Please subscribe my channel, and better you have to share to your friends also. Freely I am giving the coaching. This peak moment definitely 100% it is useful for you. And many people are without subscribing, you are watching this channel. It's okay, no problem, but you won't get clarity. When you are subscribing, you are getting the playlist. From the playlist you find it. I have given crash course and I have explained that some weightage, how you are writing the exam and what is the weightage of the chapter wise, and I have done that previous MCTS problems also. Thank you everyone.